is highly likely that at some point in your life you've taken some kind of standardized test and you've seen a question like this? What's the next term in the sequence? 2, 6, 12, 20, 30, 42, 56, and so on. So to answer a question like this, you've got to figure out the pattern or the rule that's being used to get from one number to the next. So if I examine this, let's see, to go from 2 to 6, I have to add 4, and then to go from 6 to 12, I have to add 6, and then to go from 12 to 20, I add 8, and then to go from 20 to 30, I add 10. So we start seeing a pattern. We're adding to go from one term to the next, we're adding a quantity, and every time we're adding 2 to our quantity, first we added 2, then we added 6, then 8, then 10. So to go from 30 to 42, we're going to add 12. To go from 42 to 56, we're going to add 14. So it's easy to see here, to get the next term in the sequence, we need to add 16. So 56 plus 16 is going to give us 72. That's going to be the next term in the sequence. Okay, so why am I asking you this? Well, in chapter 11, we are going to study sequences as well as something called series. So moving into section 11.1, which is titled Sequences and Series, we are going to learn the basics of sequences and series from a mathematical perspective. Sequences and series show up near the end of Calculus 1, and then they are more prevalent in Calculus 2. Okay, so like I said, in this section, we will learn the basics of sequences and also something called series. In sections 11.2 and 11.3, we are going to study two specific types of sequences and series. Okay, so in this section, we are going to start off by discussing sequences. Okay, so the first bullet point there says a sequence is a function that computes an ordered list. So we're used to what a sequence is. A sequence is an ordered list of numbers. However, when we think about a sequence, we probably don't think of it as a function. Okay, but mathematically, a sequence is indeed a function. Okay, because it is a rule. Okay, so going back to the sequence that I showed you, we could come up with a rule for this. Okay, so yes, we figured out the next term in the sequence. Okay, but we could actually come up with a formula to generate this sequence. Okay, it might take you a minute or two to come up with a formula. I'm going to go ahead and show you what it is, but the formula here to generate any of the terms in this sequence is going to be, and I'm going to use the letter n for number, n squared plus n. Okay, so let me show you how this works. Okay, so basically, let me scroll down here. I'll write it down here. So I said n squared plus n is going to be the formula here. Okay, so basically n is a number. So watch, if I want the first number or term in the sequence, I'm going to let n equal 1. So then I would plug n equals 1 into this formula. So I would get 1 squared plus 1. That's going to give me 1 plus 1, which is 2, the first number in the sequence. Okay, and then if I want the second number in the sequence, okay, I'm going to bump up my number to 2, and I'm going to plug in 2 to this formula. 2 squared plus 2 is equal to 4 plus 2, which is 6, the second term in the sequence. Okay, and if I keep going, if I want the third term in the sequence, I bump up my number to 3. Plug in 3. 3 squared plus 3 is going to give me 9 plus 3, That's going to give me 12, and I could keep doing this. Okay, so for example, if we wanted to come up with the 56, okay, that's the first, second, third, fourth, fifth, sixth, seventh term in the sequence. Okay, so I would plug in n equals 7 because that's the seventh number or term in the sequence. So plug in 7, 7 squared plus 7, that's going to be 49 plus 7, that is going to give you 56. Okay, and we could keep doing this. Okay, so my point here is that a sequence is really a function. Okay, there is some rule to follow, a formula. We plug something in and we get something out. Okay, so keep in the back of your mind as you're studying sequences that it's really a function that generates your ordered list of numbers. Okay, now when we study functions, we are used to function notation. Okay, function notation, that's that f of x business. Okay, so we might be used to something like f of x is equal to x squared plus x. Okay, when we work with sequences, although they are functions, the function notation is going to be a little different than what we're accustomed to. So if you read in the second bullet point there, it says instead of using function notation f of x to indicate a sequence, it is customary to use an, where an is equal to f of n. The letter n is used instead of x as a reminder that n represents a natural number. Recall that the set n of natural numbers is the set of counting numbers. So right here, I have the set n, which is your list of counting numbers. When you count things, remember, you start counting with the number 1. If you're counting a set of objects, you're going to go 1, 2, 3, 4, 5, 6, and so on. 0 is not a counting number. We always start with 1. Okay? So going back to the sequence that we looked at, remember, I had a rule to follow. N squared plus n. Okay? To make this completely in function notation, I'm going to call this an equals. Okay? This is going to be my formula for the sequence. Okay? This is the rule that we're going to follow, and we're plugging something in and getting something out. However, the hallmark of a sequence being a function is that you can't plug in anything you want. The number that you're plugging in has to be a counting number. So that's why I first plugged in n equals 1. That gave me a1, which is the first term in the sequence, 2. And then I plugged in n equals 2 into the formula. That gave me a2, which is the second number in the sequence, which is 6. And then I plugged in n equals 3 to get a3, the third term in the sequence, which is 12, and so on. I even computed a7. Okay, so yes, a sequence is a function. There is a rule to follow. The function notation is a little different than what we're used to. We're going to be using this an. Our variable is going to be n instead of x, just to remind us that we can only plug in counting numbers. Okay, can't plug in decimals, for example. Okay, so that's a little bit about the notation you will see with sequences. Okay, getting into fancy words with functions, domain and range. Okay, domain, remember the domain of a function is the set of all the inputs, what you can plug in. When you're working with a sequence, this is a reminder in blue, this is important, that the domain or the inputs of a sequence has to be part of the natural numbers. It's going to be some subset of the natural numbers. That's what you're going to be plugging in. Your outputs, the elements in the range, those are going to be the terms of the sequence. Okay, so you're going to plug in your natural numbers into the formula. What's going to be spit out are the terms of the sequence. Okay, if we go back to this, if we look at our sequence here, when my input was 1, my output was the first term of the sequence, a1. Okay, when I plugged in n equals 2, the next counting number, my output was the second term of the sequence, 6. when I plugged in n equals 3, the third counting number, my output was a 3, the third term in the sequence, okay? So you plug in a counting number, those are your inputs. Your outputs are going to actually be the terms of the sequence, okay? The last bullet point here basically explains what I just showed you in that particular sequence. The elements of both the domain and the range of a sequence are ordered. To get the first term, you find that by letting n equals 1. Then you get the second term by letting n equals 2, and so on. That's going to generate all the terms in the sequence, okay? In general, the general term or the nth term of the sequence is an. Okay, so for the sequence that we just looked at, the general term, the nth term of the sequence is an is equal to n squared plus n. Okay, that's how you can generate any term in the sequence. If I wanted the 100th term in this sequence, for example, that would be designated A100, that's the 100th term. You get it by plugging in 100 to the rule. 100 squared plus 100. Okay, if you compute that, that would be the 100th term in the sequence. Okay, so this is basically how a sequence works. And now we're going to do some specific examples.